Okay, good afternoon. I am Derrick Hogan here at North Georgia Technical College. I've got a little video for you all this afternoon here at Practical Machinist that I wanted to show you all about how to do some Mazatrol programming on a lathe. This is a part that I have my Lathe Operations II class make. One of the things I have them make, well, I'll just show you the entire thing so you can get a ideal what we're talking about. One of the things I'll have them make is an entire bottle jack, and I have some students to get really close to getting it complete and get it put together, but it's all the different components that go together to make this piece right here. It's quite a little fascinating project with some interesting operations you have to do both for the lathe and mill. Well, one of the pieces is this needle valve right here. This is what opens up the valving to let the fluid return to the cylinder up in here. So basically the reservoir, that is, from the cylinder. So that allows you to be able to depressurize it. So if I turn this into where you can see the wireframe, you should be able to see, yeah, there you go, you can see it in there. So you can see the needle valve goes into this piece right here, and it seals off this port here. When the needle valve is open, it allows the fluid to come back out of the cylinder and into the reservoir back up in here. So it's an important piece of this. Well, one of the things we have started to do with our students is we're introducing more and more conversational programming on the Mazak lathe that we have. And I was trying to figure out something I could have them do, and I saw this needle valve would be a great piece for that. Okay, now let's talk about why I dimensioned this the way I did. What I need to do is basically duplicate this shape as it goes along here and for my basic profile. So basically I'm going to start here at this end right here and work my way over, entering the dimensions that you see here. Now I have two options. One, I can go from this point to here, up to the top of the chamfer, over to this point, down to the chamfer, to this point, to this point, to this point, to here, or I can do from here, to here. Then there's a button that allows me to do a chamfer, to do a square corner back up to this point right here, then do a chamfer there, straight over, do a chamfer again on that one there, come over here, feed up to here, do a chamfer there. Both work, and they'll both create the same profile. It's just, two different ways to do it. Personally, to make it a little bit simpler, I think I'm going to go with this second option here. Be a little bit less data points to have to enter. So I'm going to start here and start working my way through this. So my first point is going to be a 0, 0 point right here. I'll pull a table over here so I don't have to flip around as much. Okay, so let me start here at the beginning. So I got 0, 0 here. So I'm going to start building my shape. Get back to the program here. I want to go to bar right here. It's giving you my options here. You got a lot of different options there. I'm going to go out here. Cutting point X, where does it start my cutting point at? Is going to be my point 38. Sorry, these are not showing up great when I type them in here. You can see them up here though. Cutting point Z is going to be my 0 point. Finish X, finish Z. In this case, I'm going to do like a 5/1000 finish allowance on it here. .005. And put the same thing on my X there, .0. Okay. Next comes up with my tools here. I'm going to change my finishing tool here though. I have a reason for that. But I'm going to stick with this roughing tool that you've got there. Number my pattern here. Which one I want to use. In this case right here, 1 and 2 depends on how it retracts out. 2, 3 is kind of interrupted cut here where it cuts along and it has to stop here. I'm just going to go my 0 here on that. Speeds and feeds. I'm going to go carbide auto on that again. It's going to calculate all this out. Now one change I'm going to make here, because I'm dealing with a pretty small piece, it calls for a depth of 100 thousandths there. That ain't going to quite work for me, so I'm going to go about 20 thousandths there. come over to my feed, turn my coin on here, and go down here to the base. Now I told you I'm going to change my tool here. I want to go to my nominal here, and I want to click on my tool data window here. I want to change it to this one. Tool number 2 and tool number 8 are the two tools I have, turning tools I have in here. If you look inside of here, you see tool 8 has a sharper point. Tool 2 has a shallower angle there, so it's not quite as steep of an angle. Tool 2 will not get into here as good as tool 8 will. Tool 8 will pretty much be able to rough this out and give me a usable relief here. I could come back in and do a groove here if I needed to, but I shouldn't really need it with that tool number 8 there. So I want to change this to my nominal 8 degree, number 8 here, it's called. Not 8 degrees, 8. Yeah. Come over, scroll down, scroll across, carbide auto again. Get my feed, turn my coin on again. Coin on again. There we go. So now I get to start building my profile. First move is going to be a taper move. So to cut that taper there. Start. Do I have a radius or a chamfer there? I do not there. Start point X is going to be 0. Start point Z is going to be 0. Finish point X is going to be 0.187. Finish point Z is going to be that 0.53 I have right here. So go to the 0.53 there. Any radius there? No. Angle there? No. Roughness, once again, I can do right here with this. I'm going to go with about an 8 on this one. That's my first move. My second move is going to be a straight line move back to here. So I go to linear. As you see, linear doesn't give you a start and stop point because it's going to start and stop where you left off at before. And then scroll over to here. And I want this to cut to 0.187 again. There. And my feed point here is going to be the 0.999. So I want to go 0.999. And we're good there. Okay, scroll down my next one. Now, making sure I remember this correctly on this. It's been a little bit since I've programmed this. This is how it finishes up the corner there. In that case, I didn't need that. I need to actually have my chamfer right here on the next line here. So I got a linear move here again. I'm gonna have a start chamfer of 0.029. That is my chamfer that I have here. My next move is going to move over to 1.436. So I'm going to go to a start point, final finish point X, so right here, 0.25. And I want to go to 1.436. Like so. My next move right here is going to be a linear move again. It's going to have the same chamfer cut on it. 0.029, and it's going to go back to 0.187 there. It's going to maintain that same 1.436. What I'm doing there is I'm bringing it back down into here. Next move is going to be over to 1.4561. It's going to be a linear move. So another linear move here. Nothing here. My X value stays 0.187. My Z is going to be 1.561. So that matches up to what I have on the print here. Next move, it's going to go up to my full diameter here, which is going to be 0.375. It's going to be a linear move again. linear move. And I want 0.375 right here. And it's going to stay in the 1.561. Next move, it's going to be a linear move again. It's going to have a chamfer here of 0.046. So I enter 0.046. Not 0. Get one to be 0, 0. There you go. 0.046. Okay. It'll be 0.375. And it's going to go to 2.061. 2.061. Next move, I'm going to do another little linear move down here. I'm going to cut myself kind of like a little, face it down here to get that. And it's going to go to 0.283 right there. You have a chamfer here also, 0.046. Chamfer, my dimension is going to be 0.283. And it's going to cut, let's just say basically back to 2.061. There we go. And one more move here. Linear move, 0.283. Good again. And let's go to like 2 1/4 here, 0.225. It's going to give me an area for my parting tool to come in there, kind of pre-relieves that down a little bit. And that is the end of my shape. So do shape end. Let's take a look at my shape here and see what we got. If I do shape unit here, it draws the points out. You can see how it drew out the facing. And there is our piece. So there you go. That's what we're making. So that is a turning process on this. Now the next one we go into is going to go into the threading. Then we'll talk about the parts catcher and the grooving that's necessary on this. Okay, next we're going to do our threading operation here. So we're going to click our thread button here. Give me an external. You got internal, face, or back thread here. We're going to outside here. Chamfer, I'm going to go with no here, which is a 0 entry. Thread lead. Now lead. Okay, let's do a little math here. Already pre-did this for us. On a single lead thread, pitch and lead are equal to each other. In this case, we got 1/4 28. Well, 28 threads per inch is what we need. So I need to enter on this right here my pitch here for my lead, because it's going to be the same thing because there's only one start location. So 1 divided by 28 gives me a pitch of 0.0351429. I'm going to go about 4 decimal places on that, so 0.0357 for that. So that's going to be the number I'm going to enter right here, 0.0357. Angle of threads going to be a 60 degree. Number of entrances, 1 there. Height, and it can auto correct calculate that. And that's going to give me my height value there. Got my thread tool, automatically pulled up my thread tool here. That's good. Come over. Number of pattern here. I've got some options here. I got standard, I got constant depth, constant area, standard, constant depth, constant area there. I'm just going to standard on this one. It should work fine for what we're doing here. Click auto set on my depths there. It's going to give me how many passes it takes. 7 passes in this case. Cutting speed. I'm going to go carbide auto on this. 392 feet per minute, and I'm going to turn my coolant on. Let's go down. Start point X, start point Z. Start point X in this case is going to be my 0.25. Start point Z, my threads start at 1 inch. I'm going to have them start a little bit off it. This machine does a really, really nice job of being able to start where you want it to and thread where you want it to. So I'm going to go about 0.875. My Z, 0.875. My finish point X is going to be 0.25. My finish point Z In this case, let's see, 1.56 is where my shoulder's at. So I'm gonna call it about 1.5 should be good there. It gets me right in the middle of that relief there. This one also does a really good job of managing threading. I mean, better than any other machine I've ever ran. And we're good there on the shape. So that gives me my shape here. So that's it. Threading's done. Shape check. Once again, go through my steps here. You got the facing operation. You got the contour. You get your threads. So you can see it starts a little bit off the thread and it finishes up in that V groove there. So that's good to go. Okay, the next part on this, I'm going to call up my parts catcher and part my tool off, and then send my parts catcher home. Now, it'd be nice if they had a simple little way to do this, and it's not bad once you've done it once, but to make my life simpler, I have done this. I'm going to show you how I've done it, and then I'm going to show you what else is necessary for this to actually run. So I'm going to call up a sub program I've created. My sub program is going to be, my sub program number is going to be 100. What that is a program I have written just for the purpose of calling up my parts catcher. How many times it repeats it? 1. I don't need anything there in my sequence. We're good there. Then I'm going to go to my T groove. I'm going to go T groove out. What kind of groove do I want? Gives me some options here. This is a straight up groove here. This is just going to be to part my part off. Number of grooves, 1 groove there. Pitch is going to be the same as my tool. Width is going to be the same as my tool. There. Okay, so I'm going to go to a grooving tool here, 120 thousandths basically, 118 measured I believe it is. Come over here to my next piece right here, go to my depths, carbide auto on that. That's how much it goes in before it retracts. Speeds and feeds, that's good there. Feed rate, carbide auto there, coin on, we're good. Now I'll start my shape here. My shape, I want to show you one thing here. I've got some options here. We'll get my tool data window. I have 3 different designations for my grooving tool. Tool 4, A, B, and C. Now, the difference in those 3 is which side of the tool is touching. So I'm going to show you how you can figure that out. I know which one it is. Let's show you how to figure this out. Come over here to my tool page here. Okay, you can look at my Z value on these right here. Negative 5.251, negative 5.370, negative 5.311. My home position's over here. So the bigger that negative value is, the further this way it is. Okay. A is this side of the tool. B here is this side of the tool. And C's in the center. I did that deliberately because there's times I needed all 3 of those. So I want to use B in this case. So if I go back to my program here, you'll see how it's calling up tool A. I'll call up A automatically. I want to change that to B, which is my tool that's got the right designation for me. Starting point X, 0.375. There, starting point Z is going to be my 2.061. 2.061. Finish point X is going to be 0. And finish point Z, in this case right here, I'm going to add, I think we're good there on that 2.061. If I remember correctly on this. Not 2.61, 2.061. 2.061. There we go. Taper angle is 0 there. Roughness, go to 8 on this. We're good. Let's check my shape and see what we look like here. Okay, you see how it's drawing my groove right here? That's okay because when the way I have my tool orientated. If I was pulling off the other side of my tool, I would have to, it would look differently here. So when you see this run, you'll see what I mean by this. Okay, program. Now, my parts catcher's out. It's done my part off. I need to send my parts catcher home. So I'm going to come over here, mash the over arrow again, go to sub-program. Work number here is 101, which is the one I have to do send the parts catcher home. And then go to my last little bit, click my end unit here. Does it continue? In that case, no, 0 for that. Parts counter, no, 0 for that. Return, I want to send it to my 0 position there, and we're good to go. Now, let's take a look at this, do 2 things on this. Take a look at, watch this run on the toolpath, and then go about, okay. So I'm going to draw my part shape in there, and I'm going to click my path continue. You see the facing, the turning of it down, finishing of it, threading, and then the parting right there. And you see how it draws a line right there. But since my offset is where it's at, it's going to part my piece off right there where I want it to. So that's good. And by the way, times you see that travel over this way right here is where it went home for the parts catcher. Now, let me show you what I'm talking about by the parts catcher program. Program work number. Let's go to 100 here. Let's call it up here. It's a simple program. The stuff at the top doesn't really matter. Manual programming, I put my groove tool in there so they basically didn't do a tool change right here. So I had to go to a manual program for this. So if I come down here, I have an option here, a manual program. If I pull manual program, and ask me to what I want to do here. And I sent it home, G28U, G28W for my X and Z right there. M code. M48 is the one to call up the parts catcher. That's the end unit right there. We're all good. The one to send it home, parts catcher retract, is the same with an M49 here instead. So if I go to my M codes here, let's see if it actually shows me that. I'm trying to remember, it's been a while since I set this one up for that. And it does not automatically give me that one, so that's one I had to look up in the manual for this thing to find what it was. So there you go. That's what I would have had to enter manually in there for this to work. So it works well, does what we expect out of it. Overall, makes a good part. Okay, I am Derrick Hogan with North Georgia Technical College, coming to you today for Practical Machinist. I appreciate you taking the time to watch these videos. I hope you've enjoyed them. I really hope you enjoyed today's video. If you have any comments, questions, or concerns, be sure to put those in the comment section, and do not forget to like and subscribe. Thank you so much for your time.